My name is Chieri Kubota, professor at the Ohio State University. I'm also the director of Controlled Environment Agriculture Center, Ohio Controlled Environment Agriculture Center. And we are sitting in the Controlled Environment Agriculture Research Complex. And that complex was designed to do research in a setting relevant to actual commercial applications. So right now we are in a strawberry greenhouse where we are conducting research to develop technologies to produce strawberries productively and also sustainably.
Mark Kroggel. I work in the Controlled Environment Ag program of Chieri's. I do a little bit of everything for a lot of different people, but mostly within this program. I am kind of responsible for the strawberry project that we're sitting in. But yeah, I have a very wide range of tasks and responsibilities. Mark Kroggel. So in the first year, we we knew a lot about greenhouse substrate production of strawberry. The first year was this commercial scale. So all the work multiplied by several times. However, the commercial scale is why we're in here, so that commercial growers would say, yes, this is how we do it. That first year, probably one of the biggest issues we have, which is a big issue for all greenhouse strawberry growers, is powdery mildew was a problem. We eventually managed that. The other thing that we discovered that a lot of other people were discovering at the time was Neopesthaladiopsis was in the crop, sort of a recently introduced fungal disease that was in this one sector of the strawberry propagation system. So we worked with that. We worked with the powdery mildew. We discovered through analyzing data that we really couldn't maintain the humidity in the crop. And so the humidity in this greenhouse was low enough that it would be stressing the plants. And as Dr. Kubota will tell you, that a stressed plant will have closed stomates, and a closed stomates means no CO2 uptake. And so our yields were low, but it could be because of the constant stress that they were under. So just, the fact that most of this crop season is in non-cooling periods of time, the closed greenhouse just didn't have enough humidity. So that was
Concrete floor.
Yeah.
Not much humidity.
The closed greenhouse.
We have a nighttime misting system, which we discovered 10 years ago.
Long time ago.
As an effective way to mitigate specific physiological disorder called TEPAN. During the daytime, misting was not really preferred because we don't want to put too much wet surface during the daytime. So we didn't have a good humidity control in this greenhouse. Without humidity control, it goes down to 20%.
20 to 30.
Yeah, you get heart attack if you know plants. You're growing plants in 20% humidity. So we were doing not really good job in the first year because we didn't have that capacity to. So we wanted to have something that doesn't wet the canopy, the leaves during daytime, but maintain humidity 60% at around our optimum growing temperature. So the current system works really great. Everyone likes this, workers also, right? Because you don't get wet. So I don't know if you agree, but that's what I like too. Not just plants, but workers are, stay dry. So my understanding, maybe you know better than I do. But my understanding, misting, fogging, dry fogging, classified based on particle size. Misting is the largest. Fogging, there's a sort of overlapping area. So actually the one we use at nighttime, I call misting, because the company who provide, the one we are using, I call misting, but the company calls fogging. But anyway, so based on the particle size, it's classified into 3 categories. A dry fog of AKIMist is the smallest particle. So that means more surface area relative to the volume, so easy to evaporate. And then because of the small particles, you don't feel, wet over the surface.
This dry fog system, you can see the fog coming out, but it disappears well before it hits the canopy. And I literally did stick my hand up there in front of the stream of fog, and it doesn't get wet. So it evaporates so quickly that it becomes vapor, not droplets, which is important for the crop. And once in a while they think about the workers too, so it's good for them. Water on the plant is problematic in that water reaching the plant gets into the canopy. It doesn't clear the canopy. The humidity in the canopy can become much higher than around it, and then that promotes various foliar fungal diseases and promotes botrytis. So having wetness on and in the canopy is problematic from a foliar fungal disease issue standpoint. First year, kept noticing that the fruit lacked glossiness. It just had a dull sheen to it. And that's, maybe people wouldn't notice, but maybe people would. And you expect strawberries to have a sheen on them, to be shiny. And then once we started growing with the humidity enhancement, we noticed that our berries have that sheen again. So again, not side by side, but surely a lot of strong evidence that too low humidity was causing dull skinned berries, but an appropriate humidity, for whatever reason, gave us those shiny berries that you would expect to see. Yeah, under low humidity, the plants can grow and look okay, but we're not growing foliage plants. We're trying to produce a fruit crop, so its impact on yield and fruit quality that would be most important to us. But there's a lot of other things that go on, but it's really hard to relate this to that. I mentioned powdery mildew, something like that is such an unpredictable, I'll say, disease. You know you're going to get it, but sometimes it's light and sometimes it's so heavy you're really battling it, and it's hard to define what exactly is causing that. There are multiple slight differences in the strains, so one might proliferate and one might not. But again, we're not promoting it by having dry fog. We're doing what we can to promote plant productivity without promoting a foliar disease. So the system doesn't contribute to the things that a less dry fog would contribute to. It's a difference between, do you want to have humidity and battle diseases, or do you want to have humidity and not have to worry about the humidification system's contribution to those? So, and the lifespan on these is quite long. So, return on investment, is there. I would say.
In our case, particularly, because the earlier plants are not productive, and then fruit quality was not at the standard. So in such situation, if growers have, definitely worth. Otherwise, shrinkage so huge, and then yeah. But depending on the facilities, you may not need humidification, facility location. But if you have the issue of humidity too low during the daytime, and then you are growing strawberry crop or soft fruits, definitely this is the necessity.
The system. So the installation was done in-house, and after it was all done, I think we knew that if we did it again, we'd know what to do and where to get the materials, and how to do it, and which materials to start with. Because you don't want to have to find out that the ones you started with were incorrect. So once we were done, it's like, oh, okay, we could do this again because we know about the installation details. Just the one consideration is that we are kind of stuck with is the capacity of the air compressor, which you probably want to oversize, I would say. Went right on the specs, and sometimes it's a challenge to keep up. But other than that, we have RO water, so that's not a problem. But yeah, basically, I said once we understood how it could be done, is the next time we know.
Did we need cleaning the nozzle yet? Or
no, because we have RO water.
Okay.
We're pretty good on that. We don't have any alloys in the system that the RO water would consume, so went right on. So high pressure fog systems, they're talking 1,000 to 1,500 psi, usually do require constant maintenance.
Yeah.
The nozzles accumulate.
We use a filtered water too, right?
Yeah, the water was filtered, and it was even conditioned. But the nozzle maintenance was constant.
Yeah, that's what I remember too.
And these ones, not so
No, I
much?
haven't done anything yet.
Okay.
And
2 years.
yeah, sometimes of the year they run continuously. So
we have 4 large compartments in this research facility, and 2 of those are designed for tomato, cucumber, peppers, high wire crops, so the very tall plants. Then we have a high pressure fog system in those compartments. I would rather have this one because plants are so close to the fogging system, so it gets wet. So that's very simple reason. I like to replace if possible, if there's opportunity. The number 4 compartment currently used for leafy greens, that doesn't have any humidity control, so I would be happy to have another set also in that one, because that greenhouse is 20% humidity, and I'm sure we are not getting enough. I mean, not enough, high enough growth rate. Because again, stomates or stomata needs to be widely open to let the CO2 come in. And then CO2 is used for sugar production, carbohydrates, so the building body. So if water stress because of the humidity, they might close stomates, and then that limit the photosynthesis. Then we have
we control based on relative humidity. We could choose to try to control on VPD, but we just it's good enough that we just use relative humidity. The Priva system manages that. When it exceeds the set points, it turns the fog on. The other thing that we do is we have vertical airflow, and when the fog comes on, that comes on, just to help distribute it. It's a very large volume of space, and so we like to do that. Those fans do not run unless the fog is on. So other than that, it is controlled by our Priva system, both those aspects. But it could be a humidistat, you know.
Yeah.
It could be as simple as a humidistat that you trust to turn it on and off for how we're doing it. Yeah, it was. It basically, we have control over some outlets, and the outlet opens the control solenoid and it turns on the air and turns on the system. So we turn an outlet on and off basically by Priva. The biggest advantage is you know, the evaporation rate of the droplets, which is practically instantaneous. That's our number one benefit. Two, you know, that we haven't had to do any maintenance because we're using RO water, because our components are correct. They're small. I mean, they have a pretty tiny footprint, if I can use that, in the greenhouse. Unless you point it out, some people don't even notice that it's running, except that the air compressor's right there and they wonder what that noise is. But yeah, our primary reason for using it is the dry fog aspect, and that we haven't maintained it. It's just a very pleasant surprise. There are specific seasons where we occasionally are humidifying, and because of the air characteristics or whatever, the heaters will do their pre-on fan blowing, because it cooled just enough to get down into that. But you know, that's rare. That's like a few days out of a month that you see that effect of the cooling. But as the conditions are just so, it will cool the room. As the conditions are
very important, because the U.S. education is quite, how do I say? So the engineering education, applied engineering education is very different from horticulture, agronomy education. And then often they are like silo situation, and they don't even communicate, and students don't, you know, students do not get encouraged to take the other. So, but for this type of operation, you have to understand plants, and then you have to understand system, right? And then of course, you need to understand pest and disease and maybe business side also, but it's very integrated knowledge. And so that's something Mark and I tried to introduce in the class. So we teach not just production method, but also working with sensors, working with control systems, and building little, you know, hands-on programs to learn controllers and sensors. So it's a small piece of a large picture, but I think that it's very important. And then I hope not just us, but other programs doing the same thing. Used to be just quantity, so that actually lower the reputation of greenhouse produce. But now, you know, more growers paying attention to quality and how to maintain good quality, flavor, taste year round. So that's quite a change. So it's nice. So it's yeah, so the sustainability is quite important topic, and then you can define many ways. But one way to define is the minimizing resource use relative to the productivity. So we try to minimize, of course this is a high productivity type of production system, so you need to put more resource than, you know, like a tunnel or very low-tech type of facilities. But if you evaluate the productivity per input of resource, it should be much better efficiency in that. So that's what we see, this type of operation, and then making this type of operation even more productive, sustainable, you know, reducing resource is one of the important research topics we have been working on. Yeah, so as long as you use heating, lighting, the per area based energy consumption is large. So that's unavoidable. But you get, you know, for example, 10 times higher yield or 20 times higher yield, depending on the crop though. Water usage, it's generally speaking, it's more efficient because we don't lose water. We provide enough amount of water for irrigation, and then in this case, humidification. So compared to open system, water use efficiency is very high. But you get